Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and what a fantastic day to be doing mathematics. In this specific video, we are going to be looking at exponential graphs. Now, exponential graphs or must I say are? Exponential graphs are fantastic graphs that they are so simple, but they've got a lot of small little niggly parts that can kind of trip you up if you don't know your theory. So what I want you to do is look at this sum, try it yourself. This is now a nice proper exam type question, and then hit the play button and then we look at the sum together. So when we look at the sum, the most important thing is before we attempt anything, let us interpret, okay? So what are we going to interpret? First of all, let's start by looking at f of x. What kind of a graph is f of x? F of x is exponential because it's 3 to the power of x, okay? So our x is in the power. There's a very important thing there, okay? Trying to highlight without killing it, okay? But next up, what can I say about f of x, about the exponential? First of all, that -9, that is the equation, or that's the value of the asymptote, y equal to -9, okay? Now, what does the 3 to the power of x give me? Well, it's a positive in front of the 3, so therefore it is the graph that lies above the asymptote. Very important little tidbit. Next up, the graph actually goes away from the asymptote. Now, how do I know that? I know that because the 3 is the base, is bigger than 1. Okay, if it was smaller than 1, it would have converged towards the asymptote. Okay, now let's look at g of x. G of x is a straight line, as you can see in the graph, but also it's because it has the highest power of 1. And I know that the y-intercept is at 4, and it has a positive gradient. That is very important, but although we're not going to use it that much in the graph, it's good for practice for yourself. Next up, we can look at all the things on the graph, but let's go and answer some questions, okay? That 4, I love to put on there. So what is the coordinates of A? What makes A so darn special that you would be asked to determine it? Well, A is the x-intercept. And how do I determine the x-intercept of any graph? Well, y must be 0. And it's not just for any graph, it's for the exponential graph. So 0 is 3 to the x minus 9. Now, please just wait a moment. What kind of a graph or what kind of an equation is 3 to the x minus 9? It is an exponential equation. Now, when you look back, ladies and gents, how do I solve exponential equations? I isolate the power, I make the bases equal, and then I also make the exponents equal. So let's do that. Let's take the 9 to the other side, make the bases equal, so x must be 2. Ladies and gents, this is why you solve equations in algebra, so you can apply it to graphs. Very important you make those connections. Everything you are going to use in algebra and equations, you are going to apply to graphs. Okay? Let's now look at the writing it as a set of coordinates, 2, 0. Very interesting little thing that we came across this year when marking the matric final papers. The examiners very clearly stated that if you are not going to answer the question, they are allowed to deduct a mark. So even if you got to x equal to 2, but the question asks for a set of coordinates, you have to answer a set of coordinates. Otherwise, you will lose a mark. Very important. Next question. Determine the length of CD. Again, what makes C and D so special that we ask it of you? Well, D we already have. That's the y-intercept of the straight line. But C I don't have. But it's the y-intercept of the exponential graph. So I've got to make x 0. So inside f of x, I replace every x with 0. So in other words, f of 0. And if I take that and put it in my calculator, I get -8. Which means that C is the set of coordinates. X is 0, y is -8. I put it on the graph, wrote it on the graph as well. But therefore, CD is 12 units. Okay? Now, we are not that concerned about putting in units, but, oh man, it is awesome. Why not do it? Let's have a look at the next question. Give the range of f. Now, before we actually get to f, what does range mean? Range means that, and I love interval notation when it comes to ranges and domains, because it's always got this built-in minimums and maximums, and it tells me where I want to go. So I know that I need the lowest y value, and I know I need the highest y value. Now the lowest y value, well, that's the asymptote of f of x. The maximum, well, does the graph have a highest y value? No. So in other words, my asymptote, which is -9, and my maximum is infinity. And there's my range. But wait, we forgot our brackets. Does the graph touch your asymptote? No. So it's a round bracket. Does it touch infinity? Never. Okay? And there's my range. So always with domains and range, I love to write it the way that it is. Okay? X is an element of minimum and maximum for domain, or Y is an element of minimum and maximum for range. It's always different ways that they love to ask it. Now let's look at D. Calculate the length of MN. Question, what is M and what is N? So what I love to do for my student, because they're asking me for a length of MN, which are points vertically above each other, okay? And remember that we told you that there's a 90 degrees, okay? That is important. So if I look at MN, what makes MN so special is that it is the vertical distance between two graphs. The moment I get that, I implore you, set up an equation, especially for grade 11 and 12. So I'm going to say Mn is the top y value minus the bottom y value. So in other words, the y value at M minus the y value at N. So please get this disclaimer. You can go and determine the y value at M and the y value at N and simply substitute them in. Would be 100% right. But in grade 11 and 12, it's not always going to work this way. So I'm going to take g of x, that's my top graph, take its equation and subtract the exponential graph from it. And then I interpret. Okay? So what is the interpretation? That OE is 1 unit. And it's in the positive direction. So therefore, x is equal to 1. This tells me, ladies and gentlemen, that mn, substituting x with 1, gives me a value of 12 units again. Now, this is purely coincidence that CD is 12 units and MN is 12 units. It doesn't happen often, but it's awesome sometimes when it does. Okay? Just purely by accident. Then we get to the last question. Give the values of x for which f of x is smaller than naught. Where is f of x smaller than naught? Well, remember, f of x is the y values. So in other words, where are the y values of the exponential graph smaller than naught? Well, that's all that purple highlighted part. Now, of course, it goes on to negative infinity. But the question is, give the x values. So if I look at which x values gives me those y values, it's all the x values from 2 to negative infinity, or other way around actually, negative infinity up to 2. But because we don't include the 2, okay, it's not equal to 0, okay? That's why it's not equal there. If it was equal, I would have put equal there as well. So it's always important to take a question, relate it back to your graph, and then see how it works in that way. Woo! I love this question, ladies and gentlemen. This is a typical interpretation of graphs sum. I hope you enjoyed this and I hope you learned something. But it's not difficult, guys. This is not difficult, but it does take a lot of practice. So please remember to practice your heart out before the exams. So this is Mr. VG signing out. Please tune in into our next video, which is going to jump from graphs a little bit to probabilities. So keep well. Cheers.